All right, part 3 of a multi-part series on stream flow and sediment transport now. So water carries sediment through stream channels, and we saw a bit of this in, if you watch my little stream virtual field trip, you can see that sediment is being transported, and there's different types of sediment. There's what's dissolved. It's kind of like salts, minerals that are dissolved in solution. That's what you can't see. And then you have your suspended load, which is what makes the river look kind of muddy. You know, it's not very clear and pretty. It's muddy or silty. And then you got your bed load, which includes like the stones that you use to skip, right? If you're standing along the sides of the stream, or the big sediment that is generally along the bottom of the stream. And so when rivers flow, you see we got the dissolved load. It's obviously invisible. The suspended load, which are smaller particles that are in situ being carried by the water. And then you have the bed load, which is the larger sediment that's carried along the bottom of the stream channel. Sediment in the stream can affect stream flow. Dissolved obviously doesn't, but the bigger, coarser grains can affect how fast the water is flowing. What the dissolved particles do affect, however, is the chemistry of the water. So they can actually create anoxic conditions. So when we have a lot of mud flowing into a stream, or like in construction areas where you have a lot of surface runoff, generally that can create a situation that starves little microinvertebrates of their oxygen, which is problematic. So the largest amount of sediment is called the suspended load, and this is usually really small particles that are carried downstream. You see a lot of these during periods of heavy rainfall, where areas flood and all that silt and sediment gets carried into the stream. Eventually, the river will stop or slow down, and that sediment will be deposited, and you get kind of like muddy silt deposits. And you see this again in floodplains after a major rain. If the water in the stream crests the banks, it'll deposit all of this sediment, and the whole area is just gross with muddy type silty deposits. Okay, so here's an example of a situation where you have a lot of dissolved sediment. You can see here, man, that river is just chock full. It looks kind of like milk, silty milk, because it's carrying so much of that suspended sediment. And then the bed load, what you can't see generally, tends to be coarser, larger particles. They're actually what erodes the channel for the most part, because that stuff is going to have the greatest ability to abrade rock underneath. So streams have a carrying capacity, just like the earth has a carrying capacity. And the capacity is determined by the maximum amount of particles that the stream can carry. Just like Earth's carrying capacity is the maximum amount of people that the earth can sustain with its resources. Competence is a measure of the size of sediment being carried by the stream, which obviously it makes sense that faster, steeper moving streams will have a higher competence. When the velocity of the stream decreases, then the sediment that was carried by that water will eventually be deposited. And we see this in a lot of real world examples, including Spring Run, which I took you on a little virtual field trip of. Some important features here that I want you guys to make note of. I'll change the color. We've got areas of the stream that are flowing faster, and then areas within the stream that flow a little bit slower. This would be an example of a typical stream in a flat area like the central United States. So we have areas where the stream is flowing slower, and those areas will be where you get lots of sediment deposit. And that sediment deposit is called something, we call it, it's a sandbar. And I know you guys have seen these before, and I definitely pointed them out on my virtual field trip. So these would be areas where there's less velocity, like this side of the river, and then areas where the water is flowing faster at maximum velocity, you tend to get the opposite. This is where you get more erosion as opposed to deposition. So that area creates something called a cut bank. And I know that I go over this in my video along Spring Run, but the cut bank is where the literally the ground is getting cut by that fast flowing water, which is carrying sediment. Okay. Occasionally, we get the formation of something called oxbow lakes, where rivers actually cut themselves off. So rivers, over time, they're flowing from headwaters that are steeper up at higher peaks, and then eventually over time they're going to flow along a gentle gradient. And when they start to flow along flatter or more gentle gradients, they start to do this, which is called a meander. The river starts to snake around. It's going to find the path of least resistance. It's going to, again, deposit sediment and sandbars, where it's flowing slow, and it's going to create cut banks where it's flowing faster. And eventually those cut banks might cut themselves off, and you get something called an oxbow lake, right? So basically the stream finds a path that is less resistant, and you get something like this, right? So these are like crescent moon shaped formations. They're kind of cool. You see a ton of these when you fly over the Mississippi River in the central United States. You also see a ton of this when you get to areas that are closer to the mouth of river systems like the Gulf of Mexico, or in Florida, where you have these braided streams that eventually kind of feed together and dump out at the mouth. In higher elevations, you tend to get steeper, they're called V-shaped channels. So this would be an example of a slot canyon in Utah. Definitely steeper terrain, mountainous region. Well, we're getting into dams now. That's kind of a weird transition. Anyway, in obviously flatter regions, you're not going to get those steep, narrow channels. You're going to generally get wide, flatter channels. So I'm going to go ahead and stop and do one more of these where I talk about dams and flooding, which is probably our greatest natural disaster to date. It's the one that causes the most damage in the United States. So we'll talk about that and human impacts on streams as well.